Hi, everybody. I am Stella, second year MESC at YSE, and I'm a member of BIOMES committee. As a reminder, BIOMES stands for Bridging Issues and Optimizing Methods in Environmental Science, and we are YSE's flagship series hosted by the Dean's Office. We're facilitated by a committee of students, myself included, as well as staff. And the intention of the series is to bring cutting-edge research and new ideas to YSE community. So BIOMES is a community-sourced seminar series, and we're always accepting suggestions regarding the topics and speakers. Currently, we're planning our spring semester, so please use the QR code in order to give us some suggestions on who you would like to see to brought in. Today, during the seminar, we will have the Q&A open, so please feel free to use the Q&A feature to ask the questions you might have throughout the seminar. Also, at the end of the talk, we will have the opportunity for people to ask live questions. So please feel free to raise the virtual hand during the Q&A period in order to ask your questions live. Thank you all for being here. Now I will introduce our speakers for today. It is a pleasure to have here Chris Mooney, who is a lecturer at the Yale School of the Environment for the 2021-22 academic year and a reporter on climate change and the environment at the Washington Post. He has been described as one of the few journalists in the country who specialize in now dangerous intersections of science and politics. In 2002, he was awarded the Pulitzer Prize for the articles on global warming published in the Washington Post. The lecture will be followed by a panel discussion with Simon Quinborough, Master Director of Tropical Resource Institute and the Senior Lecturer, Jennifer Mallon, Research Scientist and Lecturer at the School of the Environment and the Yale Program on Climate Change Communication, and Elena Tej-Grewal, a lecturer at YSE and the founder of the CEO of a data science consultancy, Data to the People. So without further ado, I will transfer this to Chris. Please welcome.
Thank you. Just there are the slides. Thank you so much. Hi, everyone. So it's great to be here with you. I'm Chris Mooney. And at the outset, I just want to say how excited I am to be part of this great community of scientists and future environmental leaders for this academic year. And I'm also very humbled to be working this year, at least a bit, with the School of the Environment's Environmental Data Science Initiative. I think I have a lot more to learn than I have to teach, but I guess I'll thank you for putting up with me and letting me be involved. I do come from a different profession and perspective, and hopefully just talking about that a little can prompt some useful discussions, but I'm glad that I'm not just giving a talk, but that it's actually a panel, and that we also have Doctors Marlin, Gruwell, and Queenborough here with us, and they will be talking too. So a little more about myself. As was mentioned, I'm with the Washington Post, although I'm on a leave. But I've been covering climate change for more than half a decade, and that includes traveling to some pretty extreme places like Petermann Glacier in Greenland at 81 degrees north latitude. That's where you're seeing in the picture above. And in these stories, I've often been writing about just the planet as it is struggling to keep up with everything that's being thrown at it lately. But more and more, we've also been trying to use environmental data in a pretty extensive way to advance not just daily reporting, but also to inform some major projects at the paper. And that's what I want to talk about today, how environmental data journalism has worked, at least at the Washington Post, through the example of our biggest project yet in this space, which was called 2C, or 2 degrees Celsius. And it literally drew on the contributions of over 50 journalists, including reporters, photographers, editors, graphics editors, designers, and more. And two conclusions that I think will come away from what I have to share with you are these, so you can just sort of keep them in mind. I'll come back to them. I think first, there's going to be a lot more environmental data journalism of this type by major newspapers and other media outlets, simply because it has some powerful and enticing possibilities for journalism, and so it's going to be hard to resist. And second, in many cases, this journalism will need to be done based on a lot of frequent feedback and help from scientific experts who, I hope there's some in the audience, who themselves generate much of the data and are crucial in guiding the media about its use. So just some things to keep in mind, some themes of the talk. Personally, for me, the move towards data journalism has been a natural progression. For a long time, my kind of special skill has been talking to scientists, understanding their work and how it is significant and how it has policy relevance, and knowing how to translate that to broader audiences so people understand what it means and why it matters. And I think this approach kind of came naturally because my late grandfather, Gerald Cole, was himself a scientist. He was a limnologist at Arizona State University. I think many in the audience know what a limnologist is, but for those who don't, that's someone who studies freshwater ecosystems. And he had a really big influence on me. He was kind of this larger than life scientist character as I was growing up. He was utterly rational and utterly intolerant of nonsense and superstition. And it went so far that he even had sort of an invisible friend whose words he would ventriloquize for us when we were growing up. And this invisible friend was named Chuck, which was short for Chuck Darwin. So he might say, well, as Chuck Darwin likes to say, and then a lesson would follow. So being able to relate to scientists, understanding what motivates them, how to cover their work, this is something that I did have a lot of sort of background in. But at some point writing about climate change, I guess I started to want to do a little more than just talk to scientists and translate what they knew. I wanted to look at their data too. And so that led to the 2 degrees Celsius project. And what you're seeing here are some of the many photos from it. And let me say, this talk has a lot of great photos in it. They were not taken by me. And this talk is also full of really great graphics and video graphics, which were not made by me. It is really nice to work with a team of talented people at the Washington Post. And a lot of what you're seeing is their work, not mine, but it is credited to them. And I'll mention some of them as well. The project emerged because I was starting to look at climate data, getting confident enough to do that and starting to see some patterns. And my editor, Trish Wilson, was encouraging us to pursue projects like this. So I had someone telling me this is something you should be doing. So I was seeing mentions, which I found intriguing, of places that had warmed more than the global average, what we might call hotspots. And everybody already knew that the Arctic was one of these, warming the fastest of pretty much anywhere on the planet. But the hotspots were not only in the Arctic. And in each case, with more extreme levels of warming, you started to see more extreme kinds of impacts, not surprisingly. So before long, I asked a scientist named Zeke Housefather, who works with Berkeley Earth, if he could take a look at the Berkeley Earth Global Temperature Data Set, which is one of the major temperature data sets. But if he could look at it with a kind of built-in threshold so that the data set would show which regions had warmed by 1.5 degrees Celsius, 2 degrees Celsius, and so on over the pre-industrial temperature. And the global mean is a little over 1 degree Celsius or 1.8 degrees Fahrenheit. So basically I was saying, what are the places that have warmed 50% more than that? What are the places that have warmed 100% more than that, or twice that much? And the result was a map. And this is not the initial map that Zeke sent us. It is something we were able to produce much farther down the road using that data set, Berkeley Earth, the same one. But it's basically the same principle. As we started looking at this map and many others like it, we started to see some pretty interesting things. And before long, I teamed up with a really skilled data reporter and graphics reporter at the Post named John Meiskens, who started downloading these data sets and mapping them in the way that you're seeing here. And meanwhile, I was talking with the scientists who created the data sets and who basically maintain them, just trying to understand them and to grasp how they could and maybe couldn't be used. But we were getting pretty excited at this point because looking at the maps, it seemed clear that there were stories out there about climate change that hadn't been told, might not have even been noticed in some cases by other journalists. Usually these are things that scientists had noticed and maybe published on, but those papers might be buried in the literature and might not have gotten that much media attention. The ability to work with data in this way does many things for the media, and it does many things just for daily coverage. And you can see that when you just look at all the work that is being done every day, translating all the immense amounts of data that we have on the pandemic into steady coverage. But to me, one very important thing that working with data does for journalism is that it helps us see stories that we otherwise might not have even known were there. And that was the experience with 2C, and that experience that I'm describing matches pretty well how data journalism itself has been defined by one scholar, Bahari Haravi from University College Dublin, who has written that data journalism turns on, quote, finding stories in data, and that, quote, in data journalism, data is the source. Haravi, working with Mirko Lorenz from Data Wrapper, has also documented in a 2017 survey that data journalism does appear to have a strong foothold in many newsrooms today. And of the journalists surveyed, and I think that they might have been a bit more interested in data journalism than other journalists. So I don't know if it's fully representative, but it certainly shows these are important media outlets in the US and Europe and some places elsewhere in the world. Almost half said that their outlet or publication did have some kind of dedicated way of using data and coverage. And I guess it's really no wonder, because in the media, everybody wants to have exclusive sources and to break news. And what is more exclusive than a data set that nobody else has or knows how to use or is bothering to use, that is giving you newsworthy information? And with the temperature maps, which we had set up to display these thresholds of 1.5 degrees Celsius and 2 degrees Celsius, we did feel there was a lot of newsworthy information. And I want to go into sort of one case study. So you can see the arrow. Many things caught my eye about this map, but one of them was this place in the South Atlantic Ocean off the coast of Uruguay and Argentina. It's an area that we came to call, internally at least, the blob. Something was happening here, clearly, but it was not a story I had heard of before. And I had heard a lot of climate change related stories by then. We had written on multiple occasions about changes occurring in the North Atlantic. And you can see them in this map as well, in the temperature patterns south of Greenland, where there's this strange place that is showing not only a lack of warming, but even some cooling. And that is believed to be tied to the changes in the ocean circulation in the North Atlantic. But the South Atlantic, I hadn't heard much about changes there at all. But we saw this hotspot in many different data sets, not just Berkeley Earth. We looked at NASA, we looked at NOAA, and so on. So I started reading the scientific literature to try to figure out what it might be. I think it took about a month of digging into journals and trying to call experts in the countries. And there were weeks of not finding anything that seemed that interesting, but then something really clicked. And what happened was that I found a scientist who would be a great guide to this place. He was named Omar DeFeo, and he was a marine biologist who had been studying for decades a shrinking population of clams found along. If you could advance the slide, and we'll see Omar. A shrinking population of clams found along the beaches of northern Uruguay. And these are two of his publications that I read. I read many of them. And in the process of doing this research, I think he'd been to this one stretch of beach 200 times. He'd come to know and befriend a community of fishers who had been combing these beaches and collecting clams with their shovels to sell, going back generations and maybe much longer than that. This is a photo I took, the only photo by me that you will see in this presentation, of DeFeo at the center with two brothers, Ramon and Arturo Aguero, who'd fished the beaches since they were children at their home near Barra del Chuy in Uruguay. So I called Omar, and this is the key thing. You don't just board a plane for a story like this unless you have a scientist who you know is going to be available to help you when you arrive. And the idea of going on this particular trip was kind of a big deal for me because I'd been on many big trips to do stories before, but I was actually a dad. I had a four-month-old daughter at home, so it was a different situation. It was sort of a major thing to be doing, and I couldn't have done it without my wife and my mom helping. But it was clear DeFeo was going to be available, and this was going to be a story where there was going to be a lot that was going to fall into place. That was our judgment. So he agreed to make the 200-mile drive from Montevideo with us to these beaches. And so we were soon on a plane and then in a car. And then this is the spot. It's a shoreline near the border with Brazil, where you're not going to see a lot of sunbathers. You will see an occasional horse and rider go by, and you might see someone driving a car right along atop the sand. And here is our humble species that the story was about, the yellow clam. It's a cold water species, and it had been experiencing population declines, steady declines, but also punctuated by these sudden mass die-off events as the temperature rose offshore in relation to this hotspot. And the clam was sort of the icon of the change, but there were many other related changes. The other larger fisheries were affected. And there have been severe ocean heat waves. There have been red tides increasing in prevalence and many other kinds of impacts as the water got so much warmer. And as the clam population declined, that had major human impacts. It was devastating to a community of small-scale fishers who depended upon these clams. And that includes the Aguero brothers, who you already saw. It also includes Jose Rocha, who is pictured I think it's the next two slides ahead. He had been a clam fisher for decades, but as collecting clams became too difficult because of the population decline, one more slide, I think. There we go. Because of the population decline, he opened up a bakery at his home instead for another source of income. And we ultimately interviewed many of the fishers, and they became sort of the human face in the data story. And Ramon Aguero told us of a horrifying morning in 1994 when he went out to the beach to gather clams, just the way he and his brother had done since they were kids. And he walked right into one of these mass die-off events. And as he put it in translation, kilometer after kilometer, as far as our eyes could see, all of them dead, rotten, opened up, he said. And he said he wept at the sight. He wept at the sight, excuse me. It was an alarming early marker of the transformation of a coastline and of the livelihoods of people who had become dependent on it. So stories like these helped us realize that what our temperature maps were really doing was providing a kind of directory of the places where climate change had been especially unfair. And that included places in many developing countries who didn't cause the problem, whose emissions are not particularly high, and where the capacity to adapt and respond is often more limited. And yet these were places where lives were being altered by distant chains of climatic causes. And we can talk about what caused the hotspot in the discussion if you'd like. But just because of some physical effects in this particular spot, the change was double and might have even been triple in some places, the global average. But the hotspots were also, as Daniel Pauly, a prominent ocean scientist, put it to us, quote, chunks of the future in the present, because what they're experiencing now, everyone will experience later. They're just getting there first. And so in the end, what had happened is we'd gone from climate data to a place that it had directed us to the people affected by the change in that place. And that's what made the series work. I think we let the data tell us where the stories were, and then we went out and told them. And we did that in many places across the globe. We traveled every continent but Antarctica. We visited the Sea of Okhotsk north of Japan. That's a scene of, a lot of these stories ended up being about the oceans and fisheries. That's a scene of fishing happening there. We visited Siberia. Daryl Fears traveled to Tasmania and came back with this incredible story that's somewhat similar to the story in Uruguay about the original people of Tasmania and how their cultural identity was tied to the sea, but was now being upended by another ocean warming hotspot that has emerged there. We also did a sort of separate analysis just of the United States. It's probably the most influential story of the series, and we focused on the rapid warming in the state of New Jersey, actually, if you could advance to New Jersey and New England. It was really the fact that this was a hotspot was really plain in the data from NOAA, the National Oceanic and Atmospheric Administration, but it didn't seem like it had been really highlighted in the way that we did it before. And much as was the case with Omar DeFeo in Uruguay, if we hadn't had the help of David Robinson, who's the state climatologist of New Jersey and a professor at Rutgers, who answered a huge number of technical questions from us, we certainly would not have been able to pull that story off. Another story featured the Austrian Alps. We didn't actually go in this case, but we sort of got a Zoom version in the era before Zoom being quite so popular. So we Skype with them. And here is a weather station called Sandblick, which has been in this spot on top of a peak since 1886. And the data recorded continuously here with very few interruptions since that time are very clear that 2 degrees Celsius of warming has already happened in this place. And the change is sort of staring you in the face. We interviewed Elke Ludwig, who's the head of the observatory, and she told us the mountain peak itself had to be stabilized in order to continue to have the station in this spot, because the permafrost that was sort of the substrate in this place was thawing so fast that the whole thing was at risk of collapse. So you can see in this simulation that Aaron Steckelberg did that you can see the station, its architecture, but you can also see these giant supports installed into the side of the mountain. in order to keep the research enterprise viable in this place. In this story that featured Sandvik, we also used the history of weather data, which includes millions of observations from sites like Sandvik and so many others going back to 1701, to show just how convincing the case for climate change actually is, because it rests on all these millions of historic measurements, which can't all be wrong. And in fact, if you go look at the notes, we looked at Captain Bly's notes from the Bounty before the mutiny occurred, diligently taking down the temperature and the wind pattern. And many other observers were doing this quite early on. They paint an unmistakable picture of a much cooler planet in the late 1800s. So that was the project, but obviously we couldn't do it alone. We needed the help of scientists who are willing to give us a lot of their time and to answer so many questions. And we needed them basically at 3 stages. The first stage was sort of the exploratory stage, collecting the temperature data, learning how to use it. We got a lot of help from the creators and the keepers of the data sets, including scientists with NASA, NOAA, and Berkeley Earth. Then the second phase was we needed their help telling the stories, and that's where scientists like Omar DeFeo were so central, because we needed scientists on the ground to guide us, and they also often shared more local data with us. And then third, we needed help with methodology. We were basically doing an analysis of some very central famous data sets in climate science, the global temperature data sets. These are the data sets that we turn to determine whether a given year set a new temperature record, and they make a lot of news, or whether that year ranked second or third or what have you. So they're prominent data sets. Many people have worked with them. It's just that we were doing it with a regional focus, and we were looking at key temperature thresholds and when regions were passing various thresholds. But we needed to send around a whole description of the methods to a group of experts that we trusted, and that we'd gotten to know from other stories, to basically get a critique and make sure we could do this. And several of the stories came published with their own methodology sections, which is something that you don't always see, but that was really important in this case. So my conclusion, based on this experience and based on other data projects that I worked on before coming here, hopefully some will be coming out soon, is that there are some extraordinary stories that can be told with data, and some of them might be sitting there waiting to be discovered in scientific data sets that are already published, but that have not been looked at in the way that journalists would look at them, looking for stories that can be told with them. Because we do often see data in a different way and in a complementary way. But in order to tell those stories, we need a lot of help from experts. We need to know what we're looking at. We need to be sure we're actually seeing what we think we're seeing, and we just need to get it right. But when it does all come together, it can have a big impact, and that includes an impact that I never would have expected, which is the impact within Uruguay, where Omar's research and the fishing community he'd studied for decades rather quietly suddenly were getting all this media attention because of our work. And here are just a few examples of some of the many headlines. And there were 2 rounds. First, when we published a story about Uruguay, and then when we did win the Pulitzer, there was another round of media coverage. So, after all of that happened, Omar emailed me something that I really will never forget. What he said to me was, in this email, he said, "Your report on the hotspot has had the biggest impact." Sorry, I can't read it. The strongest impact I've ever had in my academic life. Your report on the hotspot, I'll read it again. Your report on the hotspot had the strongest impact I've ever had in my academic life. And I guess I would say, Omar, working with scientists like you to try to pull off a major project like this had a big impact on me too. And it's why I'm here trying to learn more about how to use data. So thank you all so much for having me, and I'll stop there.
Thank you so much, Chris. I think I am up next. Maybe Will can advance to the next slide deck. Okay, super. I'm Dr. Jen Marlin. I'm a research scientist with the Yale Center for Climate Change Communication. And we are so happy to have you with us, Chris. That was fascinating. And that animation is just stuck in my mind of those historic temperature records. That was really interesting. What we'd like to do now is just take a few minutes to introduce a panel. And we're going to explain a little bit about what Chris is doing here with us at the Yale School of the Environment and talk about environmental data science here in the school. But we're just going to quickly introduce ourselves first. And so I'll start with my own background. So Stella briefly mentioned that I work with the Yale Center, the Yale Program for Climate Change Communication. We call ourselves the YPCCC. And we conduct large in-depth surveys in the US and around the world to really understand and to assess what the public understands and misunderstands about climate change. And really, we're trying to promote more effective communication and efforts and action on this issue. So we study what myths and misperceptions the public holds. We study what policies they support or oppose. We study what solutions people are already taking, and many, of course, are taking action. We work with partners in government and the media, with companies, civil society, and we have a daily national radio program called Yale Climate Connections. Me personally, as a research scientist here, I work explicitly on hurricanes and wildfires and other extreme weather events, and how we can do a better job of dealing with extreme weather as it relates to climate change. So I'm going to turn it over to Simon, and you can continue the introductions. We can't hear you, Simon.
Oh, sorry. I'm Simon Queenborough, lecturer and research scientist here, and I also director of the Yale Tropical Resources Institute. So I study tropical forest ecology, and in particular how climate and changing climate is affecting the coexistence and persistence of tropical tree species, and how it's changing their reproduction, and either increasing or decreasing opportunities for reproduction and food available for the animals that live in these forests. As director of TRI, I provide training for students in sort of design of projects and writing up and analyzing data and visualizing the data that they collect during fieldwork. And I'll hand it over to Eleanor to introduce herself.
Thanks, Simon. Hi, everyone. I'm Elena Graywall. It's a pleasure to be here with all of you. I am actually a New Haven native and went to undergrad at Yale, so it's exciting to be back. I started as a lecturer at the School of Environment this fall. Prior to that, I did a PhD at Stanford, where I studied social networks, and then was the head of data science at Airbnb for many years, leading a team of 200 data scientists before I started an organization called Data to the People, which is dedicated to bringing cutting edge data science techniques to study social problems. And climate change is a top priority for our group. So that is part of what has led me here. We do a lot of work on studying the impacts of different advocacy campaigns around climate change and designing experiments around those. So we did have some collaborations with Jen and the YPCC in the past, which was really exciting. And I'm here at the School of Environment teaching a class called Real World Environmental Data Science. And the goal of the course is to teach an introduction to data science and to the programming language Python to students who have potentially no prior background, really with the goal of teaching very practical applied skills of analyzing data, of collecting data, of cleaning data. And, I'm really excited about it because, to Chris's point, there are so many interesting stories to be found in data. And the more people that have the skill set to be able to look at these data sets and to bring their different perspectives to the data to see new insights, I think that that will really make a big difference for how we can tackle problems in climate change. So I'm really excited to be here and to be a part of this amazing panel.
Thanks, Elena. So just a few more thoughts here to help explain what we mean by environmental data science, because it's sort of a term that could mean a lot of different things to a lot of different people. But basically, it is a cross-cutting effort within the school. And what we're trying to do is take digital tools like satellites, drones, cell phones, and other new technologies, and combining them with the latest advances in computing and technology to solve the most pressing environmental problems. So we're working on climate change, we're working on biodiversity, we're working on environmental justice, and many other issues. And actually, Will, if you wouldn't mind advancing this slide, that'd be great. So environmental justice in particular is a key focus for many of us here, because pollution and other environmental damages have systematically impacted communities of color and low-income communities across the country and the world. And that pattern is going to continue until we start working more in a more effortful way with those communities directly to stop it. But this is just a list of some of the kinds of research that's going on at the school. And of course, environmental data science isn't just about computing and data, it's about communication and teaching, as Elena was mentioning, and it's about storytelling, which is why we are so happy to have you with us here, Chris, this year, with mutual learning going both directions. And so just this is an example of what happens when you do have a lot of data and you can tell a good story about it. What you're looking at is a picture of a map of the percentage of Americans who think climate change is happening in the US, and that's Senator Whitehouse from Rhode Island, who shared our map produced by the YPCCC program on the floor of this Senate, just to show how much strong support there is across the country to actually take action on climate change. So that always feels good to see your work having a real difference. So we just have a few more examples we want to share from the faculty and staff and students at YSE with you, and then we'll go to questions. I think you can start putting your questions in the Q&A from Chris's talk or for any of us. So feel free to do that. And if you want to change slides, I believe, Elena, you're next.
To unmute myself. Great. Thanks, Jen. So one of the aspects of the research that's happening at the School of Environment that's really exciting is the international aspect of it. The research that's happening today is really global in nature. And so this is an example of work that's being done by, excuse me, Jack Rusk and Karen Sito's lab, working on urbanization trends in the Himalayas. And their lab is showing with data that urban growth is exposing more people to climate change hazards that are increasing in frequency. And so this is really important to understand. And Professor Sito's lab is doing quite a bit of work in this area, and Professor Sito is actually leading or co-leading the urban mitigation chapter for the IPCC UN assessment, which, as many of you may have heard, released a report recently kind of highlighting the urgency around the data that is showing increasing risks because of global warming and climate change. So pretty cool to see that kind of international effort being led by professors at the School of Environment.
Next slide, please, Will.
Next slide, yes.
All right, so continuing with some more examples onto the ecological side of things. A lot of the work that would fall under the environmental data science umbrella now is using tools and techniques to link data at different scales, spatial scales, temporal scales, to answer questions that we couldn't address before. And so 3 examples of this kind of work here include work done by Professor Kamita in her lab, examining the effects of variation in climate and climate change on tropical forest tree communities. And they work with large data sets on the growth and survival of hundreds of thousands of different individual trees and seedlings across this strong climate gradient in Panama, documenting how that climate is changing and how forests and communities in those forests may change in the future and how they responded to previous climate change. Folks in Craig Brodeson's lab are doing really detailed studies of the internal structure of plants using new technologies to image and reconstruct the internal structure of plants, which is leading to new insights into how plants work and how they function, different to what we thought before. And finally, in great new faculty member, Naima Harris's lab, she uses data from hundreds of camera traps observations across field sites in Africa to document patterns of interactions between prey and predator animals and how these are being modified by the presence of human activity. Next slide, please, Will. So those are some examples of the kinds of work that our faculty, staff, and students are conducting here at YSE in collaboration with others. But we also, as a school, train a lot of students. And so we have several areas of strength in the training and teaching that we provide in terms of statistics, computing and machine learning, very strong in spatial data and GIS, and more recently focusing on visualization of data and communication. And we now even have a class on using drones to image and collect data from the field. So this is a complex flowchart, but this highlights the range and diversity of training and classes that YSE is providing, and also the links with other schools and departments within Yale and more widely to bring in expertise and to train the next generation of students. Next slide, Will, please. And so this is just one example of the kind of training that we have been offering to students that Dr. Marlon and I are doing. So this example just shows a graph that we found in the wild of banana exports from various countries over time. And what we have students do is to do what we call a makeover. So take this data, which is hard to understand, hard to interpret. There's maybe no story or clear story, at least in this graphic, and make it into something that is understandable, easy to read, has a clear message, and that they can then take those ideas and use them in wherever they end up in the future. And so we provide lots of training in visualizing data, in communicating data, using clear graphics and data and stories to help students communicate messages to a wide variety of audiences, which could be within academia, to other scientists, to the public, to Congress, as Jen said, to policymakers, as Karen Sita's lab are doing. And we do that by offering students training in a wide variety of software tools, from the sort of graphics-heavy software like Tableau and DataWrapper, which some of you may have heard of, to coding and scripting languages to allow people to automate and replicate analyses and graphics, and presentation software as well. All with an emphasis on the principles of data science and communication and the process of doing it. So a lot of this work is an iterative process where you make a graphic and you get feedback and then change it and develop the story and the graphic and the text to make sure that the message you want to convey is conveyed. And we now have a lot of students who have been through this increasingly data science intensive program, including one highlighted here, Emma Gildersgame. And she is now an environmental analyst at NUPIC, which is involved in the Northeast, looking at water quality in the rivers, lakes, and ocean seas around the Northeast of the USA. So at YSE, she worked with Dr. Marlon at YPCCC and other folks there as a social media producer. She took courses here in GIS. She took our course in visualizing and communicating data. And her internship was working with GIS with the National Parks Conservation Association. But now working with Neopic, she doesn't actually do any data viz herself, but she works a lot with other folks in her organization and wider to identify needs in communication and visualizing data. And so we've been working with her to provide some of that training. And so I think this emphasizes the fact that we're not just solely training students to do the analysis themselves or make the graphics themselves necessarily. We're training them to be able to communicate with the folks that do, or maybe are more specialized in these areas. And being able to talk to other people and sort of understand what they can do and the possibilities, I think, is a really important thing that we are training students to do here under the ADS program at YSE. So I think that's all the slides and all we had to say.
Yes, I think now we have a student who's joining us and will moderate a discussion, I believe. Off to you, Tyler.
Yeah, hi everyone, I'm Tyler Stotland. I'm a first-year Master's of Environmental Science student, and I'm actually working in Dr. Cito's lab, so it's exciting to see some of her research presented today. And I am also one of the co-presidents of the Environmental Data Science at Yale Student Interest Group. So for any students who are interested in getting more involved in environmental data science, you can always message me in the chat or talk to me later to get more involved there. And yeah, excited to be moderating the Q&A today. So first thing is I'll ask a question that I have to the panel, and then I'll take some of the questions in the Q&A feature of Zoom. If you have a question that you want to ask to the panelists, just add it in the Q&A during the discussion and I can get to that. So the first thing is I'm curious to know about how can journalists balance engaging the public with key environmental issues while incorporating scientific evidence? So often statistics or scientific evidence can be less engaging to people. So how can those things be meshed together well or better than we're doing now potentially? And how can communicators report on environmental issues in an ethical way? And to what extent is it the responsibility of environmental communicators to do so? So in other words, is it the ethical responsibility of the person communicating? Is it the responsibility of the scientist to make sure that the data is reported properly and is clean and those things? I mean, obviously it's a balance across these different players, but how do you manage ethics, I guess, in environmental reporting? So a long question.
Well, should we all? I mean, I think we all might have things to say here, but yeah. I can certainly address, the question you asked about balance between engaging the public and incorporating scientific information. It's a balance. I guess if you saw one of the early drafts of my stories, it would probably have too much scientific information in it, and then I have editors who help me achieve that balance. So, what we do is we strive to basically present enough information and explain it easily so that you get what's going on and you have some key pieces of information. But we certainly usually are not going into a lot of depth. It kind of depends. We can all easily link to more depth, and that's always good. In the 2 degrees Celsius series is a little different because there was so much depth behind what we'd done that we needed to have a method out, like a separate article. That's not going to happen that often. But also the stories were all 3,000 plus words long, so actually the explanation of the science was pretty considerable there. But even then, I mean, we tried to keep those explanations pretty quickly moving, just so that you get the processes. And of course, and just on ethics, I think that we all have equal responsibility to use data accurately and correctly, whether you're in the media or in academia.
Anyone else want to add? I think that's a great answer. And Chris, I was particularly interested in, as you mentioned, that some of your articles have had a separate methodology section, or there were even follow-up articles about that. And I think that's something that I've seen when I'm reading the news myself. I always am interested when there's a methodology section and explains how the visualization was made. And I hope to see more of that going forward.
I'll chime in here. I also, you're just reminding me that the amount of effort it takes to translate and communicate and tell a story about the scientific data often is surprisingly large. So as scientists, it can take a year or many years to produce a single paper. And I think sometimes when we get to the end of that process, the last thing we want to do is start over and try to figure out how to now translate this for non-experts or people outside of our own disciplines. And this has just become even more apparent to me teaching with Simon as we're teaching data visualization and communication. So much of what we're teaching is just that it takes a lot of effort to really think about what do people already assume about whatever you're talking to them about? What do they know? And then what don't they know? Where are the gaps? Because you don't just want to sort of put out the existing information as you find it and discover it. You want to fit that information into the existing conversation and context. And that takes a lot of work to kind of think about it from this new perspective. Scientists aren't generally trained to do that, and we are not particularly rewarded for doing that. There aren't many incentives. And so these partnerships are really critical, and more training, I think, is needed.
I would also add, just kind of coming off of that question about methodology sections, that certainly one of the big trends in data science broadly and environmental data science is this move towards transparency, both in terms of the data sets being shareable, the code being shareable, so that, maybe the conclusion someone might disagree with, but they can at least go back and be able to reproduce the results and see what steps and decisions were made along the way to come to that conclusion about the data. So I think that's one thing that has been changing and increasing, which I do think helps to have greater accountability around what is shared and reported on.
I might add a couple of brief additions to my question, sort of follow-ups from the audience Q&A. So someone asked about how do you balance telling compelling climate stories without leaning towards negative doom and gloom or fear-based framings, which are ineffective in changing people's minds or actions. And then another question, I think this sort of has to do with the ethical piece of what I asked before, which is the person said data costs a lot of money to collect, develop, and distribute. How do we incorporate an understanding of that bias in reporting and using data to communicate? So I think those are both sort of related to the discussion. So I'm wondering if any of you have further thoughts on those issues.
I can address doom and gloom a little bit. So I guess I have two thoughts on that. First, I mean, if the news is bad, we do still have to report it. And so in some sense, we can't help that people might take away a feeling, and how much of it is our framing versus what's happening. But that said, it is important to be conscious of the kind of stories you're telling. And so at the Post, and it's certainly not the only place, a whole section was created called Climate Solutions that is deliberately focused on telling stories of people succeeding at doing things that make a dent in the problem. I mean, you need so many dents, but there are a lot of them being made. So there are different kinds of narratives, and I think that something journalists always have to be aware of is not to be telling the same kind all the time. And just, you need to be conscious of your frames, essentially.
Yeah, I'll just second that. This is a really important question, especially among the climate change and biodiversity loss scientists and researchers, people who are studying these problems that are really difficult and quite horrible to think about every day. And the news that gets published is often about the latest extreme weather event or the latest statistics about what we're losing. And there are a lot of people who are just noting that there are increasing mental health issues around this. And I think I'm glad to see that people are making an effort to kind of make space to grieve these losses and notice what's happening. And yet all of that conversation is happening within a relatively small segment of the public. It's those who are most engaged already. It's probably less than 25% of the public, because the rest of the public, it's not even on their radar, or they think the impacts are largely in the future, or they're happening mainly to polar bears, and it's not in our own backyards, and it's not, harming our own infrastructure, our cities, our neighborhoods. And so it really is a balance. In our own research at the YPCCC, we're trying to convey this and help people understand that it's important to think about who you're talking to when you write your stories, and to make sure that you have a balance of doom and gloom and hope, because ideally you want to pair both of these things. And I've heard people say for every ounce of doom and gloom you need 3 ounces of hope, and to empower people to know that all of these, future disaster scenarios are not set in stone yet. We can still change the outcome. It literally depends on what we do next. So it is really tricky, but both frames are really important to communicate.
So I guess one follow-up to that would be a good way of making people see that is to try and help them to see themselves in data. And so with all these large data sets of global scale things, it can feel overwhelming and like, oh, it doesn't apply to me because I'm in this small bubble or whatever. But there are lots of efforts to try and sort of say, okay, we have this global processes, how does that affect my state or my town? And so sort of helping people place themselves in the story, I think, is a really good way of addressing that issue.
I will say that I didn't talk about it as much, but for the United States warming hotspots story, we actually, because the data from NOAA is so extensive and such a great tool, we actually were able to put essentially a toggle in where you could look at your county and look at its temperature trend. And they were all there, thousands of counties. So yeah, and I think that's one reason it was so popular. And for the hotspots, it then triggered local media coverage around the US where a lot of people didn't realize that they were living in a hotspot, believe it or not. And so it sort of touched off all these stories in different locations.
Yeah, just to chime in again, we find that also in our research that we use the term psychological distance, when you can reduce the psychological distance of the problem by helping people, put their zip code into an interactive tool that shows them what the temperature trends or climate changes are that are happening locally. That is just so much more compelling than looking at this map of the world and, trying to interpret what that means. So reducing the psychological distance and decreasing the proximity of the events or impacts is really helpful for helping people care about the issue. We also think a lot of, when we're communicating and translating science, we think a lot, and data, we think a lot about, I often know what I want to say, but I have to think about what does my audience need to hear? What do they need? What information do they need to get through their day? What is my audience worrying about? What's going to be truly relevant, the most relevant? What can they use? And maybe I can change the timing that I deliver my information. And so, for example, we know that there are windows of opportunity when people, for example, are having a about to have a baby, advertisers know that, you know, they track this information about us, and they will start sending you mailers about all the products you'll need when you have your child. But we can take advantage of this kind of insight and make sure that when people you know, go out to replace an appliance or something, or their stove breaks and they have to go buy a new one, well, that's the time when we have to encourage them to consider an induction stovetop or you know, these alternatives to help shift attitudes and behaviors in the direction of more sustainable choices and options. And so there's a lot of work to be done to figure out how can we make our science and our data more useful and get it to people at the right time and the right place. And data and technology are needed to do that with smart devices and, you know, all these advances that are helping to make these better, more sustainable choices more possible. But a lot of that has to be driven by public will and people asking for these changes, because corporations are, you know, designed to be more profitable. So they need incentive and motivation to make those changes.
I might interrupt for a moment. Amazing discussion so far. I know that Dr. Carancito has raised her hand. So Will, if you'd be willing to unmute her, then I think she'll be able to ask that question.
Terrific, thanks. Well, I just want to thank all of you for being on this panel. It's so exciting to have Chris here, and exciting to have Elena teaching a new class and Simon and Jen teaching this class. It's really, really important. My question is about psychology and knowing your audience. And I know, Jen, you've talked a little bit about this on this panel. You know, for the IPCC, we spend a lot of time thinking about our audience, and our audience is primarily national policymakers. And we have a lot of discussions as we workshop figures and data presentation about how will national policymakers view our message, right? And so we you know, because our author team is comprised of authors from all around the world, we have the benefit of people saying, well, you know, the Chinese are going to look at it this way, and the Brazilians are going to look at it this way, and oh, wait, you know, the small island nations, they're going to look at this figure this way. And so it's not just about presenting the data, it's really knowing your audience and the context with which, and this context and the psychology behind how they're going to view everything from colors to your map projection. By the way, we don't include maps in the IPCC report for that reason, for many reasons, but I'm sure you're thinking about this as you're teaching the class, and Chris, you must be thinking about this as you're writing your papers. How do you bring in the psychology and the audience part of this in both your teaching and your reporting? Thank you.
I'm happy to speak while you guys are thinking about the role of testing in this too. And, you know, I think the YPCC has done a lot of work on this in terms of understanding, you know, when you put a message out there, how do different types of people react to it, and how do you kind of maybe classify people too in terms of their psychological profiles and how they'll view data. We've done a lot of work at Data to the People on message testing as well in digital environments. So maybe the bane of the data journalist's existence are, you know, the proliferation of online kind of propaganda campaigns and misinformation campaigns. And so, you know, thinking about what kind of info are people getting through those channels too, as a part of that context, and how that might be shaping their viewpoints. We did some work in Colorado where the oil and gas industry has spent a lot of money on digital ad campaigns to shape people's viewpoints about the data around climate change and their impact. And then in that environment, we also tested different messages to try and change people's minds, and saw how those messages had an impact, and related that to the YCCC profiles. So I think that, you know, there's a lot of data research that's being done to help with that process, which is really exciting and, you know, important for helping to inform those decisions.
I don't know if I could leap in. So I will say that I guess I have two answers. So in the media, it's not quite the same thing as psychology, but we know a great deal about audiences because we see how they respond to content. So over time, you notice a certain story structured a certain way is read widely or is not read widely or shared widely. That does tell you a lot of things. And so I guess we get a lot of insight there. But I do think it is imperative, I guess I'm repeating myself a little bit, to think about the way that stories are framed and how that will access different audiences. I did one story about the increasingly severe impacts to the Florida coral reef. It's the third largest coral reef in the world, and it's gotten not nearly the attention of the Great Barrier Reef in terms of what's happened there, but the impacts are quite severe. And in that story, we really did tell an economic story about tourism and about just how much the Florida Keys, and to some extent Miami, but especially the Keys, really depend upon this reef. And I think it was a conscious choice to highlight that because we weren't sure how people relate to a coral reef. And so it seemed like that kind of frame was probably one that would draw in. So I think we are practicing this. I think that there's always a lot to learn, and we should really consume research about audiences as much as we can, actually.
So thank you all for the incredible discussion. Unfortunately, it is 1:02, so we have to wrap up. But yeah, thank you all for being here and for contributing, both our panelists and our attendees. You can look out for future biome talks that will be coming up, and we'll cover lots of different environmental issues. And the last thing is I want to plug again the Environmental Data Science at Yale, or EDSY, so EDSY, student interest group. And that is a group for any YSE students, or honestly, even beyond the School of the Environment. If you're interested in getting involved, you're welcome across any skill level, whether you're just curious about environmental data science, learning about more about what it is, or if you're an expert in Python, anyone is welcome to join. And so I'll put my email right now in the chat. And so you can reach out to me if you want to learn more about that group and get more involved in many of the topics discussed today. So thank you all. And yes, that will be the conclusion.
Thank you.